Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the balancing condition of the Wheatstone Bridge, and after that we will learn Metre Bridge also. Okay, so let's start the video, and the derivation we are going to do, that is also very important for the board exam. Okay, so here you can see this is the Wheatstone Bridge, and here you can see four resistances are there, P, Q, R, S, and this is the galvanometer that is used to find out the balancing condition. If the current will flow, that means the bridge is not balanced. If the current will not flow, then only the bridge will be balanced. Okay, and this is the cell. Now, so I hope so this basic circuit diagram you have understood very well. Okay, so see here what we can see here, because we have to write an example like this. It is an arrangement of four resistances. You can see very well P, Q, R, S, which can be used to determine one of the unknown resistances in terms of the three known resistances as shown in circuit diagram. Okay, and remember that here this unknown resistance, you will see the Metre Bridge, it will be S, and the known resistance, it will be P, Q, and R. Okay, this will be the known resistance here. Okay, and if we talk about here one more thing, this P by Q, this will be called here the arms ratio. What is the name here? Arms ratio. Okay, now after that, see here, the bridge is said to be balanced when current through the galvanometer is a 0. As I have told you very well, bridge will be balanced when the current through the galvanometer will be how much? 0. Okay, so let's take here, for example, I have taken here some points here. This is point A, this is point B, this is point C, and this is point D. Now, and let's take here, for example, see here, let's take the current in this galvanometer is given by IG. Okay, the current through this galvanometer is given by how much here? IG. So as I have told you, the current through the galvanometer should be how much? 0. Okay, so mathematically what will be this? This IG should be 0. Okay, then I can write here IG means from the Ohm's law, potential difference, that means potential at point B, now here, minus potential at point D by the galvanometer resistance, that means G. So IG means VB minus VD by G should be equal to how much here? 0. Okay, so from here we can tell that here this VB should be equal to VD. That means the potential difference of point B and the potential difference of point D should be what? Means potential should be same. Potential at point B and potential at point D should be equal, or we can tell potential difference will be how much? 0. Okay, so this is the equation 1. Now this is clear. Now after that what we'll do here, we'll write here we'll use somewhat KCL and all. So let's take here, for example, here the current is flowing I1. No? Current is flowing I1. When the current will reach here, you know, in the galvanometer there is the no current, then we can tell here the complete current will pass through the resistance Q. Similarly, let's take here from this side the current will go I2. Okay, and again from the galvanometer no current is coming, that means here also how much current is this? Here also the I2 current will go. Okay, that means what you may think, from the battery how much current is coming? I1 plus I2. Is it? Now after that, if we write here the little bit KVL, so see the current is going in this direction, that means this plus, this minus. Similarly, this plus, this minus. Current is going this side, this plus, this minus. Here also what we can tell? This plus, this minus. Is it? So now if I write here the some equations and all. Okay, so first I am going to find out the ratio between VA minus VB by, now see here, A to B, VA minus VB, then B to C, and I can write here VB minus VC. Okay, so what can we tell here? Tell me here, potential difference between points A and B, VA minus VB, is given by resistance, resistance P and the current I1 multiplication from the Ohm's law. So I can write here I1P. Similarly, VB minus VC is given by what here? I1Q. Okay, I1Q. So what we can tell? I1 cancel, and we can write here P by Q. Is it? So VA minus VB by VB minus VC is how much coming here? P by Q. Is it? Great. Now after that here, again if we'll go for this one, down one. So what we can write here, see the students here, if I write here VA minus VD by here VD minus VC. What this will become here? Tell me here. VA minus VD is here, this D is here. No, don't mismatch here. V is the battery. If you wish here, no, this battery voltage you can write here, not a problem. Okay. So VA minus VD will come what here? I2 into R, no, from the Ohm's law. And VD minus VC will come what here? I2 into S. I2 into S. That means again I2 cancel and we can write here R by S. Is it? So you can see very well we have got here these two. Now, and we'll make it here. Let's take here this is equation 2 and let's take here this is equation 3. Now, equation 2 and equation 3. Now we'll just go ahead here. Now, so see the students, as I have told you very well. See, this is VA minus VD by VD. See, VA minus VD by VD minus VC. Is it? So this is VD minus VC is how much here, students? Here we can write here R by S. Is it? R by S here, see, R by S. Now what I will do here, wherever this VD is there, this VD will be replaced by VB from equation 1. Wherever VD is there, this VD and this VD, what I will write here? VB, because potential of point B and D is equal. Okay. So wherever VD is there, I will write here VB. So kindly see here, VA minus VB by VB minus VC is equal to R by S. Okay, now see, this one we have written from here, this one we have written from equation 1. Now, from equation 1. Now we have got what? VA minus VB by VB minus VC here now. Now you check here, see here, this one you check here. VA minus VB by VB minus VC. What is written here? P by Q. That means left side of that equation I can write here P by Q. Now left side of that equation we can write here P by Q. Is it? That means we can write here, see, what is this? This is the P by Q. So P by Q is equal to R by S. Now, and from here we are writing from equation 2. Is it? So see, in how much easy way we have got the balancing condition of the Wheatstone Bridge. P by Q should be equal to R by S. So we can tell here, see, this P by Q should be equal to R by S. Or even we can tell P by R should be equal to Q by S. That's not a problem. You can see from that equation also. Okay, this is clear. Now after that, if we write here some important points, so see, very, very important point. First one, very important. Question used to come in the exam. See, the bridge remains balanced even after interchanging the positions of cell and galvanometer. So if we interchange the position of cell and the galvanometer, what will happen? The bridge will be balanced. Okay, so see here what we can tell here, this is the thing. No? So see here, let me write here, see, this is the thing. What was this? This is P, Q, R, S. Okay, and here this was the battery. This was the battery. And here it was the galvanometer here. Is it? So now what I am going to do here, I am just going to interchange the position. Okay. So let's take here also, what is this here? This is P, Q, no? This is R, and here resistance S. Is it? And here, see here. Now what I am going to do here? Here I am going to connect here the battery. Okay. And now here I am going to connect here the galvanometer here. Okay. And I can write here the names also, see. A, B, C, D. And here also see here A, B, C, D. So in this you can see very well, galvanometer and cell. Galvanometer and cell. What is happening? The position is interchanged. So even in this situation also, what will be there? The balancing condition will be same only. P by Q equal to R by S. In competitive exams, they used to ask from here. Okay, very, very clear. I hope so. Okay, now let's see next one. The bridge is most sensitive when the resistances in all its 4 branches of same order are almost equal. That means PQRS, there should not be too much gap. Okay, then only it will be most sensitive. The galvanometer can get a 0 deflection very easily. Okay, great. Third one, see here. If, very, very important condition, see, if P by Q is less than R by S, then VB is greater than VD and current flows from B to D. Okay, current flows from, see this one here. Current flows from B to D. Sometimes question used to come, you have to just check here, P by Q ratio, R by S ratio, if P by Q is less than R by S, and if we are connecting them just by a wire, no, or through any resistance, then current will flow from where to where? B to D. That means from high resistance to the low resistance. high potential to the low potential. Okay. See fourth one. If P by Q is greater than R by S, then VD is greater than VB and current flows from where to where? D to B. It is students, so remember that here condition, current will always flow from where to where? High potential to low potential. So in first case, point B to point D, and in second case, from point D to point B, depending upon these situations. Okay, P, Q, R and S. Is it great? Now students, see here the meter bridge, very important now, because as we have told that Wheatstone bridge is used to find out the unknown resistance, is it? So see here how this meter bridge will get in a lab and all that here. It is based on the principle of Wheatstone bridge, as I am telling you. It consists of a wire of length 100 centimeter. 100 centimeter means 1 meter. That's why the name is meter bridge, which is made of constant tin or magnet. They are alloy. Alpha approximately 0. Alpha means coefficient of means thermal resistance. Coefficient of thermal resistance. Correct? Coefficient of resistance. Coefficient of thermal resistance here. Okay. So alpha will be approximately 0 here. So that resistance of the wire should not change with the temperature. When alpha is nearly 0, then what will happen? That the resistance of this wire will not change with the temperature, and balancing condition will be very perfect and error will not be there. Okay, now after that, see here, to find out the unknown resistance, the jockey J, I'll show in the diagram, is made to touch from A to C, and balance condition is found. Okay, let balance condition is at B on the wire here. Okay, so see here, this is the meter which looks like this. This is the wire AC of how much length? 1 meter length here. Okay, so if you compare with the previous, so you will see in a Wheatstone bridge between A and B what was connected? P was connected, the resistance was P. B to C what was connected? Q was connected, is it? And when you will check out A to D, what was connected? R was connected. This is called the left gap. Which gap here, students? This is called the left gap, and this is called here the right gap here. Okay, and remember that here what will connect here? Here will connect here the R, that is called the resistance box. See here will connect here the R, resistance box, known resistance. Okay, and here. Okay, and here also, see here will connect here this. Like this. Here you can write here it will be S. Now this is the S here, this is the S here. Okay, and what is this? This is the unknown resistance. R is the resistance box, known resistance. S is the water, unknown resistance here. Okay, and this point is also, this is D here. Okay, now after that what will be there? The jockey will be connected between point D and B. Like you can see there, the galvanometer was connected between B and D. So here also remember that here what we have done? P, Q, R, S, like this here. And here what is this? Here this is the galvanometer. Okay, and here this is the jockey. Now jockey. So this is the situation. Left gap, right gap. I hope so this is very, very clear. Left gap, right gap, is it? So P, Q, R, S. So you know very well mathematically what we can write here, students. We can write here P by Q is equal to R by S. Now see, P by Q is equal to R by S, is it? Now what is P? Let's take resistance per unit length of the wire is small r. Okay, and this length is a small l. Now small l. If the total length of the wire is 100 centimeter, then this will be how much here? 100 minus L. L centimeter, 100 minus L centimeter. Okay, so we can write here P means R into L. Q means we can write here R into 100 minus L. R into 100 minus L is equal to R by S. Okay, and what other things will cancel out? This R and R cancel, is it? That means this unknown resistance S is given here. Very, very easy. See, 100 minus L by L into what? R here. Okay, put into the box here. Remember that here, students, this L in centimeter here. Okay, I am writing here this L in the formula in centimeter. And what is R? R is the resistance per unit length. R is what is this, students? Resistance per unit length of wire. Is it? So can you see very well? No? Just based upon the Wheatstone bridge only. So students, I hope so. This Wheatstone Bridge and the Metre Bridge concept you have understood very well. In next class, we will solve questions and all that. Keep studying, keep growing.